Question number 23 on page 449, it gives us a linear system, which is ax plus by equals c and dx plus ey equals f. So it's all in variable terms. And they give us this bit of information here that a times e minus d times b equals 0. And it asks to show that the system does not have exactly one solution. Okay, so first we'll just start with exactly one solution. So when we talk about exactly one solution, it means the two linear systems have different slopes. Okay, so that's what exactly one solution means. So this question says, does not have exactly one solution. That means then that we need to show that the slopes are the same. So if exactly one solution means different slopes, then not exactly one solution means the same slopes. Okay, so it's binary. So if it's not one, it's the other. So that's what we're trying to show. So there's a few ways we can show that that system has the same slope. And this AE minus DB equals 0 is important information because what it does is if I rearrange that, I get AE equals DB. Well, that's a ratio relationship. And I can see that ratio more clearly when I write it, when I cross multiply that and write that as E over D. So I'm going to divide both sides by D. And then on the right side, it equals B over A. So I divided both sides by A. And that means then if I can show that that ratio exists in the linear relationship, then I have the same slope. So the easiest way to do this problem really is just to rearrange those linear equations into slope-intercept form. If you know the formula for the getting the slope from this general form type, then we can do that as well. But I'm just going to show it to you in slope-intercept. So I'm going to take the first equation, and I'm going to do by is equal to negative ax plus c, and then divide both sides by b. I get negative a over b. That represents my slope. And plus c over b happens to be the y-intercept, although we're not that interested in that. So the slope is equal to a over b, negative a over b. For the second equation, I'm just going to rearrange this into slope-intercept form again. So E is equal to negative dx plus f. Okay, rearranging that again, dividing by E, I get negative d over ex, there's my slope, plus f over e, and again, this just happens to be the slope, the y-intercept, but we're not super interested in that. So what we can do then is we can compare these two linear equations, so we can see that they have these slopes. And that original relationship in red says that ED over BA is E over D is equal to B over A, or I think I've got it upside down. We could also say that D over E is equal to A over B, and we can see that those slopes are the same in those two equations. We could even put a negative on there to make them exactly the same, but since those two slopes are the same, I'm going to write this out, slopes are same, slopes are equivalent, therefore not one solution.